Welcome, Professor Donald Hoffman, who is a professor in cognitive science. He earned his BA from the University of California, Los Angeles in quantitative psychology, and his PhD from the Massachusetts Institute of Technology in computational psychology, which we were in the same department. I also have a PhD from brain and cognitive sciences, and it's a joy to see one of our common alma mater, our graduate of this great institution. Professor Hoffman has continued to develop a mathematical model of consciousness and has used that model to solve the combination problem of consciousness, which I hope we will have a chance to also discuss. So welcome, Dr. Hoffman. Don, it's a joy to be with you. You are an icon in science and philosophy nowadays, and many of your thoughts meet ours and mine, and ancient knowledge also, hinting to the importance of consciousness, where everybody is on the physicalist level, through their senses, through their experience, feel that reality is what we see through our senses. And you have broken through that kind of dogma, if you like. People usually talk about dogma when it is something of a belief or of a spiritual kind of connotation. But here the dogma is about actual physical reality. So welcome to this podcast and discussion. And I hope you can explain to all who are with us, listening and also seeing, what is that started your thinking about this wonderful investigation about reality and your ability to transcend, go beyond the surface value?
Well, thank you for your kind invitation, and it's a pleasure to talk with you, Tony. And my thoughts on this evolved heavily at MIT. So I was a graduate student in the brain and cognitive science department there, as were you. At the time it was called the psychology department. It's changed its name since to the
Right.
brain and cognitive science department. And I was working with David Marr and Whitman Richards on mathematical models of perception. And our idea at the time was that perception was a probabilistic inference, and what we were doing in perception was trying to infer the true state of the world, not the whole world, but just those aspects of the world that we needed to survive. So there was this evolutionary idea that sensory systems were shaped by evolution to report the truths that an organism needed to survive in its niche. And so we used techniques of Bayesian inference to estimate the true state of the world, at least those parts of the world that we needed. But as I was working on this, I began to question whether, the Bayesian inference idea was great. I really liked Bayesian inference, but it may not be that we were actually estimating the truth. And so I began to think about that, and it occurred to me that we could just be seeing what we needed to see to act appropriately. In other words, evolution shapes sensory systems to keep you alive. Everybody would agree on that. And at least everybody who buys evolutionary theory would agree that sensory systems are being shaped to keep you alive. And they assumed that also entailed that they were shaped to show you those truths of the environment that you needed. But I began to actually ask the technical question, does evolution by natural selection really entail that sensory systems would be shaped to show us the truth? And so I began to suspect that fitness and truth are very, very different things, and we're shaped to be fit, but that doesn't mean that we're shaped to see the truth. Well, working with my colleagues Chetan Prakash and Manish Singh and some graduate students, Brian Marion and Justin Mark and others, we did some simulations using evolutionary game theory. So evolution by natural selection is now a mathematically precise model. John Maynard Smith in the 1970s, a brilliant mathematician, took the tools of game theory and applied them to evolution by natural selection, and we now have evolutionary game theory and evolutionary graph theory. And so we can start to ask technical questions about what evolution by natural selection will do. And so we ask the question, what is the probability that natural selection would shape sensory systems to see any truths about objective reality? And the answer is the probability is 0. I mean, it doesn't mean that it can't happen, but you would bet strongly against it, right? So the probability is 0 that any sensory system of any organism has ever been shaped to see any truth or perceive any truth about objective reality. The only exception, this is just a little technical aside, are something called measurable structures. So something called measurable structures, which are critical for probabilities. So there, the theory of evolution by natural selection assumes that any measurable structures in the world are perceived, at least we see homomorphisms in our perceptions. Otherwise, we couldn't do science. If probabilities of events in reality are unrelated to probabilities of events in our perceptions, then science isn't possible. So natural selection does require that one structure, measurable structures, but that's it. The shapes of objects, three-dimensional space, none of that is required. And in fact, for that, the probability is precisely 0. So that was a bit of a shock. And I've started to get some expected and welcome pushback from my colleagues who are trying to run new simulations and see if they can't find some exceptions. And they find that if you have like thousands of fitness functions and require an organism to not carve the world into objects, then you can find in that special case, you can get systems evolving to see the truth over just fitness. But what we find is that if you allow organisms to take the fitness payoff functions and group them into clusters, so hierarchically cluster them, and then create pseudo objects for the cluster. So this cluster of payoffs, we can call this object and have this collection of actions on this object be a representation of the set of actions that these fitness payoffs are associated with. When you do that kind of clustering, then the probability that you see reality as it is goes back to 0. And of course, we see objects. So this is good. This is what we expect in science: is you put out your theory, and then your colleagues don't just say yes. They try to push the theory, and so we're doing the normal scientific thing. I would say one thing about this, and that is that science for centuries has been built on the ontology of physicalism, right? The assumption that space-time and its contents, particles and objects, energy in space-time, that ontology is fundamental. And as a corollary in some sense, that reductionism, methodological reductionism, the idea that as we go to smaller scales in space-time, we can find more fundamental laws of nature. So that's the reductionist methodology. Those have been, for centuries, spectacularly successful, right? Science is really using that ontology and that methodology had tremendous success. But what's really impressive is our best scientific theories, evolution by natural selection, and also quantum field theory. Those theories they're the product of this ontology and that methodology, but those theories clearly tell us that space-time is doomed, that space-time is not fundamental, and that therefore the reductionist methodology has only limited use, and we're reaching the ends of that limit. So what's wonderful about science is we started with these heuristics, the ontology of physicalism and the methodology of reductionism, but the precision of our theories then came back and told us that those assumptions aren't true, that we have to go beyond those assumptions. And so that's the power of the scientific method, is that it's not stuck on any ontology or any particular methodology. It asks only for precise theories, and those theories can then, we hope, will tell us where our current assumptions are wrong and then force us to explore new assumptions. So that's the fun about science. Individual scientists, of course, are human beings, and we're just as dogmatic as anybody on the planet. But science as a social institution, when you look at it over long enough periods of time, is not dogmatic, right? Physicalism isn't going to go away overnight in science, but I predict it will go away because our best scientific theories are telling us that space-time is doomed. And so when our science tells us that space-time is doomed, scientists eventually wake up. I mean, the physicists are already there. The neuroscientists are going to take probably a few more decades, right? Because this is not their field. It's hard to believe what the physicists are telling us, that space-time is doomed. It's not fundamental. And so our whole understanding of cognition as being, and consciousness as coming from the brain, as coming from something inside space and time, can't be right. It can be a useful heuristic for research, and that's perfectly fine. But ultimately, we're going to have to dig deeper.
This is wonderful. It joins some ancient understanding. You know, there was a time when consciousness was primary. I refer back to the ancient Vedic traditions, what they call the Advaita Vedanta, and the teaching that consciousness is primary, and in fact, also that consciousness is all there is, because it's a very monistic vision of reality. But then there were so many philosophical understandings and suppositions that science said, well, this is all, we don't know how to prove it. Let's go to the physical, because the physical, we see it, we touch it, we can analyze it, and then go to the objective level, not the subjective approach, which is to look through consciousness into the nature of reality, through reasoning, and beyond reasoning, through transcending and direct experience. And then we got the physicalist realism, the physical realism, that said, well, the objective, we have to be objective, keep the observer out of the observation, and then explore the ultimate of objectivity. And we find that the ultimate objectivity has actually met the ultimate subjectivity, which is, in a sense, consciousness. And one thing very important to be able to overcome is that sense of absolute truth about what our senses show us, that this is the reality. And you've done a marvelous work and reasoning in actually deconstructing that and showing it from logic and experimentation and even computational analysis and mathematics and all of that, that actually our senses are only showing us part of reality. And we know this through psychology, of course, and neurology and neuroscience, how much our brain reconstructs reality, whatever we see, and gives us a certain impression about it. So the difference between vision and perception, if you want to say something about this and how the brain actually does, what is the mechanics that does that?
Right. So the standard view has been that what the brain is doing is essentially a Bayesian estimation of true parameters of physical reality around us. So there really is an apple in front of me, and it really has a particular shape and a color and a texture. And my senses do Bayesian estimation to estimate the true color and shape and texture and distance and so forth. And that's why my PhD was called computational psychology, right? It was these computational methods, Bayesian inference and so forth, presumably in pursuit of the truth. But the glory about scientific theories is that they're precise. And they're precise enough to tell you where the limits of those theories are, and also the limits of your own assumptions in making those theories. So we came to the idea of Bayesian inference from an evolutionary framework. My advisor, David Marr, was very explicit about perception evolving to in more advanced creatures to actually, estimate the true shapes of and distances to objects around. But the theory is very, very clear. The probability is zero. It's a theorem of evolution by natural selection that the probability is zero. So it's not that we estimate part of the truth. We don't estimate the truth at all. That's the whole point, is not to see any part of the truth. Instead, the analogy I like is a user interface, like the desktop interface on your computer, right? Where you might have an icon for a file that you're editing, an email that you're going to send to a friend, and the icon might be blue and rectangular and in the middle of your screen, but that doesn't mean that the email itself is blue and rectangular in the middle of your computer. Anybody who thought that misunderstands the whole point of the user interface. It's not there to mimic the truth. Quite the contrary, it's there to completely hide the truth, which would be, in this case, the diodes and resistors and voltages and magnetic fields inside your laptop or your mobile device. If you had to toggle voltages to send an email, your friends wouldn't hear you. I mean, if you actually had to deal with the truth in this example of toggling voltages, good luck trying to send an email. So that's what evolution has done for us. It gives us a user interface. Our senses are a user interface that allow us to interact with objective reality, whatever it might be, even though we're all, arbitrarily ignorant about the nature of that reality. And so from the science point of view, physics, by the way, I should say, agrees that space-time is not fundamental. So our belief in space and time, which we get from our senses, I mean, that's what we see when we look around, is space and time and objects in space-time. Physics has come to the conclusion, and this is a quote, that space-time is doomed. So Professor Nima Arkani-Hamed at the Institute for Advanced Study at Princeton, and others, David Gross, a Nobel Prize winner for his work in quantum field theory, these geniuses of mathematical physics are saying that space-time is doomed because the mathematics is telling them that. But the mathematics doesn't tell you what's next. What is beyond space-time? And the same thing with my work on evolution by natural selection. It tells me that our senses are an interface. They're not telling us the truth. They're an interface to an objective reality, but it can't tell me what that objective reality is. So that's the fun of science. As scientists, we then have to take a creative leap into the dark and propose something. And of course, our proposals will probably be wrong, or even if they're not terribly wrong, the details will be off. And so that's just the way science is, and that's my attitude about scientific theories in general, is that there is no theory of everything in science. We can't have a theory of everything for two reasons. First, because a scientific theory has to make assumptions. Like when Einstein has his theory of special relativity, one assumption is that the speed of light is the same in all inertial reference frames. Well, so we're assuming that light exists. We're assuming the notion of the speed of light. We're assuming the notion of reference frames. We're assuming a lot. But if you grant me that, then you can show, then you can show that we get these Lorentz transformations or the Poincare group, and a lot of physics falls right out of that. So it's amazing what you get from special relativity. But Einstein, toward the end of his life, admitted, I've been spending my entire life trying to figure out what light is, and I don't know what it is. And light was the fundamental assumption of his theory of special relativity. And this is just the way scientific theories must go. We must make assumptions. And then we say, if you grant me these assumptions, then I can explain all this other stuff. So we have a theory of everything except our assumptions. And if you then get a new, deeper theory that tries to explain those assumptions, you'll get a new theory with its own assumptions. And so you'll get a new theory except for the assumptions of that theory. So in principle, scientific theories can never be a theory of everything. They can only be a theory of everything but their assumptions. And hidden behind those assumptions are whole universes of explanation that have yet to be explored. A second reason why there can't be a theory of everything in science is Gödel's incompleteness theorem. That Gödel showed in 1930-31 that in mathematics, if you have a set of axioms that's rich enough to derive all of arithmetic, then there are true mathematical statements that cannot be proven from within that axiom system. So they're true, and you can show that they're true, but they can't be proven from within that axiom system. If you add that new true statement to your axioms, then Gödel shows there'll be yet new truths that you can show are true, but can't be proven from within the axiom system. So mathematics can never be turned into a computation. We can't just set up a set of axioms and a set of derivation rules and then compute all the truths. Truth goes beyond computation. No finite system can do it. So mathematical foundations are the key of scientific theory. So we inherit this Gödel incompleteness stuff in our physical theories to the extent that they're rigorous. To the extent they're not rigorous, I'm not interested in them. To the extent that they're mathematically rigorous, I'm interested, and then they inherit this Gödel incompleteness. So what we find in science, and as you pointed out, Tony, science early on just said, let's forget about consciousness and subjectivity. Let's just focus on what we can see and measure and so forth. And looking back, hey, you have to start somewhere. So hats off to the early scientists who did that. They were trying to make, how do you start? So, great start. Very, very smart to do that. And we made a lot of progress to the point where we then realized you can't assume that space and time are fundamental. And you can't assume that our perceptions are telling us the truth. So all of a sudden we have a big rug pull, right? Our own science has pulled the rug out from under us on deep assumptions that we wouldn't really have questioned too seriously, but now we have to question them because our best theories are telling us that we have to question them. Now, I should say that as a scientist, this doesn't tell me what is beyond space and time, right? The science doesn't tell us. So when you and I both start talking about consciousness being fundamental beyond space and time, we are making a leap beyond what the science entails, but we have to make a leap. And our goal then is to make that idea precise, mathematically precise, and show how a mathematical model of consciousness could, without any hand waves, give rise to space and time and all the physics and evolutionary theory that we know inside space and time. In other words, when we say that consciousness is fundamental, that doesn't mean that we're throwing away all the science we've done. By no means. What it means is all the science that we've done is an absolute constraint on any theory of consciousness that we're going to propose. Whatever we propose, if we cannot derive space-time and show how quantum field theory, general relativity, and evolution by natural selection arise as some kind of projection. So we have this model of consciousness and its dynamics. Whatever that is, when we project that into space-time, we have to get back evolution by natural selection or generalization of it, and also quantum field theory or a generalization of quantum field theory. Otherwise, there's absolutely no reason for scientists to take it seriously. So people might say, well, you're talking about consciousness is all squishy, you're no longer in science. Absolutely not. These are the strong restrictions on anything we propose in a theory of consciousness where consciousness is fundamental. We have to project back into space-time and get our current loved theories in space and time of evolution with natural selection and quantum field theory, or generalizations of those theories. If we can't do that, then there's absolutely no reason for our colleagues in science to take us seriously. We have to do our homework and come up with those theories before they should even give us the time of day. So the burden's on us.
Wonderful. Just as a starting point, though, however, we can think that we have an empirical starting point by saying that consciousness is, if we go back to even Descartes' time and the Cartesian thinking, that they had the intuition at that time, and others also, we have Leibniz, we have Spinoza, we have even Schopenhauer and Carl Jung and all of that, and many thinkers that have gone into this field. And just to simplify, Descartes, saying, okay, I cannot get rid of the reality of the physical world, because he didn't have at that time what we have today and what the research you have done and the thinking that you had. He said, well, we have to accept that, but we also have to accept the reality of my consciousness. And in fact, when the physical is so much changing and it's never the same and it's all like that, so they had the intuition that at least I think, which means I am conscious. That's what he meant, really. Therefore, I am. And therefore, that's quite an empirical starting point. And so I don't feel this is like an axiomatic start, but it's an empirical start of the idea that consciousness is real. And so that is maybe what you also define as conscious realism, or what I would call consciousness realism, if you like, that there is something that is consciousness. And we are starting with the idea that it's beyond time and space. It's not something limited within time and space. It is not physical. It is not a thing. And so it, in a way, goes beyond the beginnings and ends, the definition of object as such. And yet there is this hiding value that you have highlighted also, where reality is, on the living level, is being hidden, or to live in the existence, one has to hide certain aspects. So otherwise everything appears as flat consciousness in a sense. So I don't know if you have read my book, One Unbounded Ocean of Consciousness, which
some of it, but not the whole thing. Yes.
Yeah. So this is one starting point. Now the question is, we can go into the idealism and panpsychism, and you have beautifully defined that panpsychism is different than your feeling of what reality is. So if we were to explore the second part of your thinking, in a sense, let me call it this way. I mean, you have many parts, but there is one part which deconstructs reality as being physical and sensory. And there is another part which is a bit of theoretical, if you like, where you say, well, let us attempt, what is it you want us to grant you, so that you can build a theory of reality.
That's right. So when I was a graduate student, and when you were a graduate student at MIT, it wasn't kosher to talk about consciousness, right? We could talk about brain activity and perception, but not consciousness. But now many scientists are really serious about trying to understand consciousness. So Christoph Koch, for example, Francis Crick, of course, was very, very famous for saying that we need to get in there and start studying consciousness. And so now for the last 2 or 3 decades, there's been a lot of work by scientists. And as you point out, there are panpsychists who basically assume that there is a physical world, space and time are fundamental, particles are fundamental, but certain particles like electrons and protons also have a fundamental unit of consciousness. And you have to then, when you put an electron and a proton together to make hydrogen, you somehow combine the consciousness of the electron and the proton to make the consciousness of the hydrogen. And I'm not a panpsychist, because panpsychism misses what physics and evolutionary theory is telling us. Space-time is not fundamental, and therefore physical particles are not fundamental. So panpsychism is sort of like a dualism. It's saying that these particles are fundamental and consciousness is fundamental, and I'm saying that doesn't pay attention to our best science, which says space-time is doomed. So get over it. Particles don't exist when they're not perceived, and so they don't have consciousness either. If we're going to put consciousness there, it's going to have to be something more fundamental. Now, as you well know, many of our colleagues think that consciousness is not fundamental, that the brain is fundamental, and consciousness is perhaps an illusion. So Keith Frankish and Dan Dennett are sort of in that camp, that consciousness is an illusion that is created by our brains. And others will say it's not an illusion, like Patricia Churchland, but that we're deeply wrong in our intuitions about consciousness, and really it's all that really is there is brain activity. That's all that really is there, and folk psychology and so forth. Parts of it will have to be eliminated, and parts of it will have to be deeply revised. But the idea that consciousness is fundamental is not there. So among our colleagues in the neurosciences, almost none of them, even though they're studying consciousness, take consciousness as fundamental. The panpsychists will take it as fundamental along with physics, but the physics can't be fundamental. So we're in a very interesting place. So I decided with my colleagues that I collaborate with, I mentioned Chetan Prakash and Manish Singh and Robert Prentner and Federico Fagin and Chris Fields. I've got many. So it's not just me. I've got a wonderful team that I've been working with. We're working on a mathematical model of consciousness, qua consciousness. So not consciousness as somehow emerging from brain activity. Quite the opposite. It'll be that consciousness is fundamental. We'll show how space and time, if we're lucky, we'll show how space and time and brains emerge from consciousness, not the other way around. And the model, if people are interested and want to get into the math, I have a paper called Objects of Consciousness. So if you just Google Objects of Consciousness and my name, it's online for free, so people can see the mathematical model. It involves Markovian kernels and Markovian dynamics, and I'll talk a little bit about what it means in terms of current spiritual ideas from the East and the West. But it's a mathematically precise model, which, and again, my attitude is, of course I'm wrong. This is just, consciousness, in my framework, 1.0, and presumably as time goes on, we will see that there's a 10.0 and a 1,000.0 and so forth, that will just continue. And that's the way science works. And this is also what the spiritual traditions tell us, that thought can never, ever get the whole of reality. Our conceptual systems are very, very limited. And this is true of our scientific theories. This means that it's great to be a scientist because you have infinite job security. You will never get the final theory of everything. And from a spiritual point of view, as you well know, the spiritual traditions tell us that our thinking, as smart as it may seem, only scratches the surface. There is this deep intelligence that transcends all thought, including scientific theory building, and we can only get pointers in conceptual pointers into that deeper realm. But what's interesting is that science gives us really good pointers. And so we want to understand what makes for a good pointer, and versus pointers that we look and go, oh, that was a terrible pointer. That really took us down the wrong track. And I can give you an idea just what I mean by a good pointer and a bad pointer. So a lot of people know about the numbers called the integers, 0, 1, 2, 3, and 0, -1, -2, -3. So there's an infinite number of integers. Then there's the real numbers. These are like between 0 and 1, there's a whole bunch of real numbers, 0.999999993. And if you think about it, there's countless numbers, literally countless numbers, yes,
between many infinities.
It turns out to be a bigger infinity than the number of integers. Well, can we approximate all those real numbers with integers? Well, not very well, because between 0, there's no integer between 0 and 1, and there's an infinity of these real numbers between 0 and 1. So the integers are not a very good pointer into the real numbers, right? Because they're just leaving so much out. But here's an interesting pointer. If you take 2 integers and take their ratio, like 2 divided by 3, or 9 divided by 10, or 9 billion divided by 999, whatever it might be, you can get, it turns out, these are called rational numbers. It's a ratio of two integers, and you can get as close to any real number as you wish with rational numbers. And in that sense, even though the number of rational numbers is only the same as the number of integers, it's a surprise. The number of rational numbers equals the number of integers, but the rational numbers give us a better pointer to the reals, although they could never, there are infinitely many more reals than there are rational numbers. Nevertheless, they're a much better pointer than the integers. And so in spiritual traditions, for thousands of years, we've had to use words as pointers. Now, with science, we can begin to sharpen our pointers. And this is where I'm hoping a scientific spirituality will evolve, where we take the insights from the spiritual traditions and understanding full well that no description is the truth. But some descriptions are better pointers than others. We use the tools of science to craft ever better pointers to consciousness, which is what we are. Right? In some sense, we can't conceptually know the truth, but we can be the truth because we are that. And so as scientists, we can begin to use meditative techniques, which allow us to let go of our conceptual system and our theories for a while and immerse ourselves in our being, that deep truth. Then we can come back from that and get little pointers that can be very helpful to us and to other people. And, this may be what consciousness is about. I mean, you might say, why does consciousness bother with all of these space and time and objects and so forth? And I don't know.
I have some pointers for that.
You have some pointers. And I'll put out one pointer for it. And that is, again, Gödel's incompleteness theorem. Gödel's incompleteness theorem, if consciousness is fundamental, and that's all there is, then it means that mathematical structures are only and always about possibilities of consciousness. And then Gödel, his theorem tells us that there is no end, in principle, to the exploration of possible mathematical structures. And therefore, in a world in which consciousness is fundamental, there's no end for consciousness to explore its own possibilities. And so Gödel's incompleteness theorem, I mean, I'm not saying this is right, but it's the only idea that I've run across that's deep enough to be scientifically interesting to state about it. So it entails that what consciousness is about is the, in principle, endless exploration of the possibilities of consciousness. And what space and time is, in all the objects that we're seeing around us, is just one little bit of the explanation, the exploration that consciousness is doing. Consciousness somehow seems to plunge itself completely and get lost completely in its own creation of form, like space and time and objects, and then over a lifetime wakes itself up and realizes, as vast as this space-time universe is, trillions of galaxies and so forth, I'm not that. I'm something deeper than that. So and this process then would not be just in our little space-time. That's just one little bit of this whole exploration that consciousness is doing. And for us as scientists to model this, we're going to have to show, if we think of consciousness as timeless, we're going to have to show a mathematical model of consciousness in which it's timeless, and then show how our perception of time emerges with mathematical precision. And I'll just sketch an idea about the kind of thing. And so in the model that I'm working on, it's a Markovian model. And again, I'm not saying I'm right. I'm just saying I'm trying to be precise. We'll probably find that there are ways to take that using deeper mathematics, category theory, for example, to lift the probabilistic Markovian models to higher kinds of categorical kinds of things, and that's perfectly fine. And then we'll probably go beyond that, topoi and other things like that. But right now I'm dealing with these Markovian models that are stationary in the sense that there is no entropic time. So here's consciousness. It's a dynamical system, but there's no time in the sense of increasing entropy. But you can show, it's a trivial proof, that if you do any projection by conditioning, and this is interesting that spiritual traditions also use the word conditioning, that there's this deep consciousness and ours is just a condition, our perceptions are just conditioning. Well, it turns out in a mathematical technical sense, it literally is conditional probability that we use as the projection. So that conditioning, you can show, leads to entropic time. So when consciousness, which is timeless in this entropic sense, decides to project itself into an interface, into a user interface, to look at itself through that interface, then time is an artifact of that projection, and you get this entropic time. So that's really quite beautiful, and it's going to be very interesting as you take different projections from different conditional probabilities, you'll get different rates of entropic time. So it'll be very interesting to see, can we show how the Lorentz transformation, Einstein showed that time varies from observer to observer. Sometimes time can stop if you
travel at the speed of light,
yeah, time dilates. So if time is just entropy and different projections lead to different entropies, then we might be able to show how different the groups of these projections can lead to, in special cases, the Einstein special theory of relativity and the Poincare group that's just fundamental in our particular physics. And this might actually be a way for us to bootstrap, right? The goal of trying to show how the Poincare group could arise may give us an insight into the dynamics of consciousness and the projections of that consciousness that lead to the particular space-time with the Lorentz. So in other words, here's where science can work with spiritual ideas and use the current science to then get pointers into what does conditioning mean? Well, it could literally mean conditional probability. And what does it mean that the timeless becomes immersed in time? Well, it could be that a non-entropic dynamics of consciousness becomes an entropic dynamics necessarily when you take. So in other words, you can see how the ideas that have been in spiritual traditions could actually be made mathematically precise. And again, I'm not saying that my way is the right way. It's just a precise way so that we can find out the limits of that way and move on. And that's what I'm hoping to see in science and spirituality. I would feel that we failed if in a century we're using the same words that we've been using for the last several thousand years. What we want is, what I would love is, going to a meeting where the guru or the minister or whoever says, look what we just discovered this week, some new theorems, some new pointers that give us new deep insights into who we are and what kind of conditioning we're underneath and how we can wake up. That's what I would like to see.
That's wonderful. That's wonderful. Just to highlight an important point, and that is having consciousness and being consciousness. They can be two different things. When we say having consciousness and say panpsychism or others that define objects as having consciousness, and now we're talking about actually being consciousness, and that consciousness is timeless, is beyond space and time, beyond definition of objects on a surface sensory level. And yet the dynamics of consciousness, its interaction with itself, lead to all the phenomena that we experience and that appear to be the universe as it is, which has its own realism on a certain level, because every moment of experience, which I like to call usually a bit of consciousness, one bit of consciousness, as a moment of experience, it has an observer, an object that it's observing, and a process that connects them together. So consciousness as an existing entity as a being, as an ontology, has a nature, we can say. What is the nature of consciousness? The nature of consciousness is to be conscious, because that's why we're calling it consciousness. And to be conscious entails an observer, a process of observation, and an object. So it kind of curves onto itself. Consciousness curving onto itself allows all of this creation to happen. And this is something mentioned in the Upanishads and the Bhagavad Gita and the ancient knowledge, that curving onto myself, I create again and again. So consciousness is conscious in infinite number of ways. And that is the seed of the multiplicity out of the unity of consciousness. Because we have to explain how that one consciousness, one unified field of natural law, ultimate field, if you like, to go from molecules to atoms to elementary particles to fields of energy, and then, as you know very well, of course, scientists trying to unify those fields, electromagnetism, weak, strong, and gravitational fields, and ultimately a theory of a unified field. Well, if that one field is a field of consciousness, curving on itself by its own nature, because it is conscious, appears as many, which means it is experiencing itself in so many infinite number of ways. And if they are these ways, then we have to perceive time and space as the void, if you like, the nothingness of consciousness that separates objects. Because otherwise, if everything is melted together, then you don't see different objects. So the illusion actually of time and space is to separate these different modes of consciousness, these different ways of being conscious. So this is one way of also looking at what you've been saying from this perspective.
Absolutely. This idea that of consciousness turning in on itself and exploring itself, that self-reference thing, that's very, very deeply important here. It's also, even for those who don't take consciousness as fundamental, like Douglas Hofstadter, he's got a book called I Am a Strange Loop. And he focuses again on that self-referential aspect of things. When you sort of when you have sentences that turn on themselves, like a sentence that says, this sentence is false.
Yeah.
Right. When you look at a sentence like that, you get, so this sentence is false. So is it true? Well, if it's true, then it's false. Oh, well, okay. Well, if it's false, then it's true. So all of a sudden, the notion of what's going on here, when you get self-reference, you get all these really interesting things
Right.
coming out, and also you get the point that when you have self-reference from a computational point of view, right? What when you're trying to understand yourself computationally, what you're doing is building a model of yourself, right? Well, in the process of building a model of yourself, you have changed. You're now more complicated. So
Yes.
now the thing to understand is more complicated than it was before you built the model. So now you have some more work to do. And that process is never ending. And so you get hints in this direction. Even though some of our colleagues who are physicalists wouldn't go this direction, they would say, it's I think Douglas Hofstadter is a physicalist, and so it's consciousness is not fundamental, and the self is a loop that the brain makes. So the brain is fundamental, and neural circuits are fundamental, and so forth. But we're taking a very different framework now. We're saying our best science tells us that space-time is doomed. So the brain isn't fundamental at all, and brain does not create consciousness. So we're saying, okay, to be in line with our best current science, if we're going to talk about consciousness, it can't be deriving from physics. It has to be sui generis, on its own. And in that case, we have to show how space-time arises from consciousness. And of course, when you mention fields of consciousness, you're talking about consciousness as primary, not like quantum fields in space and time. You're talking about something far deeper than quantum fields. You're talking about fields outside of the notion of space and time that would then give rise to space and time. So absolutely agree. And what's interesting, I'll just say about the mathematics we're exploring right now, is that we have this notion of a conscious agent. It's a mathematical definition, and that paper Objects of Consciousness has it. But it turns out to be a very simple theorem that when you have two conscious agents interacting, they form a new conscious agent. They are a conscious agent. So there is, in other words, all these conscious agents are one conscious agent, but they're also many conscious agents. So the mathematics gives us a way of understanding how there could be one consciousness and yet a dynamics of consciousness, each part of which, in some sense, is a reflection of the whole. And then how that could be a timeless dynamics in the sense of no increase in entropy. So there's no entropic time. And yet any particular projection of that onto a particular subset of conscious agents will have an entropic time. And so we can see what the spiritual traditions have been saying for thousands of years. And I'm a scientist, but I've spent a lot of time now reading and thinking about the ideas from the East. Of course, as a scientist, I take nothing, including my own theories, at face value. I question everything. I mean, you have to question everything and ask for better and better pointers. So it's not a matter of dogmatism and saying I know the truth and you've got to believe. It's rather being open to these perspectives, looking at the pointers that the Upanishads and Advaita Vedanta and Buddhism and Judaism and Christianity and Islam, the Sufism, they've all given us pointers. And it's our job to be open to the pointers, but not to be dogmatic about them. So, okay, what can I learn from these pointers? How can I transcend these pointers? And how can I get to new, deeper pointers? And can we have this process continually evolve? And I think that's what consciousness is about, is trying out pointers, saying, great pointer, okay, time to drop it. Now let's move on to new pointers. And that process never ends.
This is wonderful. So exploring consciousness from the physical perspective, the analysis on what physical is, and exploring consciousness from reasoning, thinking about it using our intellect, but also exploring consciousness from direct experience, which means exploring consciousness through consciousness. Yes. And that's really the process. We've talked a lot, the term transcending came a lot. And that's what we actually have been through, myself personally, transcendental meditation, which is a technique that allows the mind to settle down and experience deeper levels of understanding and experience. You know, it's like we project ourselves through our senses to the outside. And as you beautifully said and demonstrated and analyzed and mathematically computed, that this is a false reality. That is not the truth about the ultimate reality. But closing the eyes and diving deep, not only through reasoning, which is one aspect, but through direct experience, we have found that it is possible to directly experience that pure consciousness, that one consciousness, which is the ultimate inner self of everything and everyone. And so that is going beyond, you said, the pointers, going beyond the surface, going beyond the sensory perception, and knowing consciousness as consciousness. So that is really a beautiful experience. I actually invite you to try it. We can arrange to make sure you can see what transcending means and transcendental meditation. That is a mechanism of exploring consciousness through consciousness itself.
Absolutely, and I completely agree that it's clear that from this framework, any conceptual system can only be a pointer. The reality completely transcends it, and so letting go of any conceptual system is absolutely critical. Now, I've actually been meditating for 20 years.
Wow, what technique do you use?
So it's the technique of going into pure silence. So I sit. I don't have any particular posture, but I'll sit in silence. And if thoughts come up, I just look at them and let them go, and go back to silence. And and it absolutely is possible to be aware without any content, to
Beautiful.
to be aware and
To
have
transcend.
to transcend and to experience just pure awareness without yeah, it's sort of a timeless feeling where okay, yes, this isn't time anymore, this is just just pure awareness. And of course the mind will jump back in, but that seems to be part of the whole dance, that I mean, pure awareness wants to then go back into form and explore, and then go back into pure awareness. And by the way, I think that this is going to be a really valuable tool. That's not a good word, but an approach for scientists in the following sense, that that if I think the really greatest scientists with the greatest ideas get them from the silence, right?
Yeah, yeah.
It's not just all intellect and thought. They go deep into silence, and you get hints from, Einstein said that he didn't think in words. He did images and deeper stuff, and it took a while to translate this stuff into words. And I think that future generations of scientists that have let go of space-time being fundamental, and if this idea that consciousness is fundamental pans out somehow, then what we may end up doing is as scientists be very practiced in the scientific methodology of rigorous experiments and mathematically precise theories and testing, but also that recognizing that we're not separate from what we're studying, we are what we're studying, and spending time free of concepts, in silence, in transcending all of our theories, is the way to tap into an infinite intelligence that we can't know, but we can be. And we can then take back into the realm of form pointers, new pointers. And that may be what consciousness is all about. And maybe this wedding of science and spirituality is just another step in the evolution of what consciousness is about, which is knowing itself better and better.
Beautiful. This is fantastic. This is exactly the vision that completes the picture, really, of the meaning of life also. So that adds to a new dimension, of course. That is a new hypothesis, supposition, theories, again, that, as you say, you don't want to commit to or say they are the final truth, but it adds to so many levels of what are we doing here, what is it all about, what's the meaning of life, where are we going. And quite some ancient sages and knowers of reality have explored that in so many sense. And I particularly know this very powerful technology of consciousness, which comes from the Vedic tradition, that has been a tradition of consciousness, exploring consciousness and its techniques. And that's how these techniques of development, techniques of consciousness, that's how we developed, for example, a university that is based on consciousness. We call it consciousness-based education, and transcending and transcendental meditation. So this is really wonderful, as consciousness, in a sense, goes into exploration of all its possibilities and then comes back to its full possibility. And that's what we're really doing, because what you're doing is saying the physical is not what it appears to be to the senses, right, but my reasoning tells me it's my reasoning. So a deeper level of approaching reality is through the intellect. A deeper level than the intellect is through being, through directly exploring through consciousness. Yes. And ultimately, reality goes back to itself and through our evolution. So evolution will ultimately, I feel, reveal true reality, so we can know the mechanics of what is happening behind the scene, and maybe be able to be the engineer that works on the computer that makes what appears on the screen even more effective and more functional, if possible. What do you think about that?
I agree. I agree with your the whole thing that you were saying there, it from one perspective, you might say, consciousness has been pursuing both routes. For thousands of years through the spiritual traditions, it's been learning about itself, exploring itself. In the last few centuries, maybe some Greek stuff too, you might call a little early science, but certainly, since Francis Bacon and so, it's been taking this very rigorous approach to self-exploration, and now in conversations like what we're having, we're seeing the hints that we could maybe these two different aspects of consciousness exploring itself can start to dovetail, and to get the rigor of science, the intuitions and insights of the spiritual traditions, and have a new and even more powerful way for science to take the next step in its self exploration. And I agree with you that technology that could be mind-blowing will come out of this. Every time that we get new rigorous theories, even though they're not the final word, they open up new power. So in the mid 1800s, Michael Faraday had been doing these brilliant experiments on electricity and magnetism, and had just a genius. And then Faraday's work,
Maxwell and Faraday.
Yeah, Maxwell, right? Yeah, no, James Clerk Maxwell, right? So Maxwell took a look at all of those experiments and wrote down some equations, Maxwell's equations, and they're not the final word, but they were brilliant. And the reason we can talk right now is because of Maxwell's equations, right?
Right.
So if we're in the place where our physics is telling us that space-time isn't fundamental, and physicists like Nima Arkani Hamed and others are looking for structures beyond space-time. They've got things like the amplitude-hedron, cosmological polytopes, associahedron, and so forth. These are structures that seem to be true of so-called scattering amplitude data for scattering processes at the Large Hadron Collider and other colliders. So they're finding these structures that are beyond space-time, that are capturing important truths about the symmetries in the data and insights about the data. But they don't know what this realm beyond space-time is about, right? All they know is, we've got this mathematics, it accounts for our data, but what is this realm beyond space-time about? What's going on here? What gives, right? And they don't know. It's so this is where, again, I think that consciousness can provide a link. We might be able to show how a dynamics of consciousness gives rise to the structures that they're finding beyond space-time. Could a dynamics of conscious agents give rise to the amplitude-hedron? That would be, if we could show that, then we have something really interesting there. Plus, as you were saying, new technology. So if space-time is not fundamental and we find these deeper structures that we can start to play with outside of space-time, maybe something like this could occur, right? It turns out when we look into space, we see trillions of galaxies. Most of them we could never get to. Even if we could go at the speed of light, we could never reach them. They're moving away from us too fast, and so we could never catch up with them. So there's all that beautiful real estate that we can see, but we could never go to. And I think it's the vast majority of it we can't get to. Over 90%. I forget what the number is, but it's a lot of it we can't get to. Well, even going to our nearest star would take us several years at the speed of light. And to the nearest galaxy, millions of years. I think to get to Andromeda would take, I forget, 3 or 4 million years to get to the Andromeda galaxy. And that's our nearest galaxy. So this is clearly not feasible with current technology. But what if we didn't go through space-time? What if we realized that space-time is just a data structure, and we then understand how to just circumvent it and go around it? So this is even different than creating a wormhole through space-time. This is right. Somehow just saying that space-time is a data structure. Once you understand that, you can just play with the data structure and somehow go around it. Will that be possible? we'll see, but at least put that idea on the table to really open up the technology that may come out of this.
This is wonderful, opening up the field of all possibilities and all dimensions through the beyond space, beyond time consciousness and being. And that ultimately is, I am sure from my perspective, I mean, sure, I don't want to be non-scientific by being making such a statement, but it's a feeling, it's an intuition, and a conviction at some level that this is where we're going. And it's been a delight to be with you, to explore these thoughts and dimensions of being, dimensions of what reality is, and beyond what people assume reality is, deconstruct the surface and go to the source, and from the source build up a field of all possibilities, which is full of hope and perspectives and dynamism for all humanity and all our direction of evolution. What a joy and a delight to be with you, Dr. Hoffman. It's been great. I look forward that we meet in person and discuss more of these topics and complete the picture in a way that is satisfactory scientifically and spiritually.
Yes, thank you so much. It's been a real pleasure to talk with you, Dr. Nader.
Wonderful. Take care. All the best.